Today we are going to talk about the Born-Haber cycle. Before that, what is the Born-Haber cycle? The Born-Haber cycle is the application of Hess's law to ionic compounds. Before we go into that, let us see the steps that are involved in the formation of an ionic compound or in the Born-Haber cycle. In the first step, you have the formation, and the formation is where you write an equation to represent the whole reaction with the elements in their standard state to form the ionic compound, and the enthalpy of the reaction represents the enthalpy of formation of that particular compound. So for example, in this particular example, you have magnesium chloride. So magnesium, which is a solid, is in its standard state, and then chlorine, which is also a gas, is in its gaseous state, and they are forming magnesium chloride. So that is the first step. The second step is atomization, and atomization involves forming gaseous atoms of both the metal and then the non-metal. In the example of magnesium chloride, you need to change the magnesium from the solid state to the gaseous state, and that is called atomization. Remember also that changing a substance from the solid straight into the gaseous state is also called sublimation. So, in this particular example, for metals, their atomization energy is also their sublimation energy. The enthalpy of atomization is also the enthalpy of sublimation for metals. Then when you come to the diatomic molecules, for instance Cl2, when you separate them, you are getting 2 atoms of the Cl2. So which means that whatever enthalpy you have for the atomization of chlorine, you are going to multiply it by 2 because of this 2 there. Now let's go to the next step. The next step is ionization, and of course, we are forming an ionic compound, and therefore we will need ions to form the ionic compound. So the magnesium changes to the cation, which is Mg2+, and then by losing 2 electrons, and then the chlorine changes to chloride ions by accepting 2 electrons. But the loss of the electron by the magnesium is systematic. It is one after the other. So for the magnesium, it will lose 1 electron to form magnesium plus. Then magnesium plus will lose another electron to become magnesium 2+. So for magnesium, you are going to have the first ionization energy and the second ionization energy. But for chlorine, you are only going to have electron affinity because it is accepting electron to become -1. But it will be 2 times the electron affinity because you have 2 chloride ions involved. Let us go to the next one. Okay, so this is a continuation of the magnesium example. The magnesium will first lose 1 electron to become +1, then it will lose the other to become +2, and so you have first ionization energy and second ionization energy, and then the electron affinity of chlorine times 2 as it appears here. Now lattice energy. This involves the ions combining to form the ionic compound. The energy released is usually high, which means that lattice energy is highly exothermic, since the ionic bonds are fairly stable. So the magnesium cation, which has been formed already, and then the chloride ions combine to form a magnesium chloride solid, and the energy change involved here is called the lattice energy. Most of the time it is difficult to calculate lattice energy, and that is where the Born-Haber cycle comes in handy. It helps you to calculate lattice energy of ionic compound. So this is a summary of everything I've spoken about. Now let's go through this chart. Here you have the magnesium solid and the magnesium chloride gas in their standard state, and then as they combine, because it is exothermic, the energy level is below, the energy level of the product is lower than that of the reactant, and that is why you see the energy level of the product down here. Now from this state we move to the enthalpy of sublimation or atomization of magnesium. So magnesium changes from the solid state into the gaseous state and becomes a gas, which is the enthalpy of atomization or enthalpy of sublimation. After that, you dissociate the chlorine gas to get 2 atoms of chlorine gas, and that gives you 2 times the atomization of chlorine, which is also equal to the dissociation of chlorine, enthalpy of dissociation of chlorine. So 2 times enthalpy of atomization of chlorine gives you 2 atoms of chlorine. After that, this magnesium, which has been turned to a gas, loses 1 electron, which is the first ionization energy of magnesium. So it loses 1 electron, and all these processes are endothermic. So you see that the energy is rising because it is endothermic. Magnesium gas becomes magnesium plus, and then that is plus 1 electron. Then the magnesium plus also becomes magnesium 2 plus. Then these 2 electrons are accepted by the chlorine atom to become chloride atom. It becomes chloride atoms, and then the 2, I think this should be 2, so, and then they combine to give you magnesium solid. So from this point to that point is the lattice energy. We will also look in other videos, we will look at different examples of ionic compounds, that we will look at how to draw the Born-Haber cycle for other ionic compounds. Thank you for watching.